In this lesson, we will learn how to factor polynomials completely by grouping. Factoring polynomials is similar to factoring numbers into their prime factors. So suppose I wanted to factor this polynomial here. Notice that this term has a factor of x plus 1, and this term has a factor of x plus 1. Since they both have a factor of x plus 1, I can factor that out. Okay, so I factor out x plus 1, and I'm left with, on the inside, 3 minus 2x. You should be convinced of this because think about it in reverse. Let's say I needed to distribute this x plus 1 inside. Okay, the x plus 1 would get distributed to the 3, and the x plus 1 would get distributed to the negative 2x, which would result in this polynomial here. So what allows me to go from this to this is the distributive property. So let's suppose that I wanted to completely factor this polynomial here. We're going to use a technique called grouping. The first thing I want to do is find the greatest common factor of all four monomials. Notice that negative 2x will divide all four monomials, so I factor that out, leaving me with this polynomial. So at this point, the only thing I've done is just factored out this negative 2x, which is the greatest common factor of all the terms. The next thing I do is I group the terms that have a common factor. Okay? Notice that x cubed and x squared have a common factor of x squared, because x squared goes into x cubed, and similarly, the common factor of 3x and 3 is 3. So I group them because what I want to do next is I want to factor out the common factor of each group. So now that I've grouped x cubed and x squared, I want to basically use the distributive property in reverse to factor out that x squared. Right? So this will give me x squared times the binomial x plus 1. Right? So this now becomes the same as this. Similarly, over here I do the same thing. Notice that both of these, once again, have a greatest common factor of 3. So I factor that out using the distributive property backwards, and I get this product, 3 times the binomial x plus 1. But if you notice here, both of these terms have a common factor of x plus 1. So I can use the distributive property once again to factor that out. Okay? So I factor out the x plus 1, which is the common factor of the products inside the brackets, which leaves me with the following product. So basically what I've done is I've taken this polynomial and I've systematically broken it down until I am left with only multiplication. So these are the factors of this polynomial here. One more example. Of course, make sure that you come to class prepared for these reflect questions. They're probably going to be asked for in a notes quiz. Okay, leading into our next example, we need to talk about something called binomial opposites. So just like numbers have opposites, binomials have opposites as well. For example, let's say I have the binomial 3 minus x. Its opposite would be negative 3 minus x. So, but notice that I can, the expression negative 3 minus x, it can be rewritten as negative 3 plus x. Why? Because I can just basically distribute this negative 1 on the outside into each one of these terms using the distributive property. So once I do that, if I distribute this negative sign inside, I get negative 3 plus x, which also, notice a different way I can write this is x minus 3 by the commutative property. So, in conclusion, 3 minus x and x minus 3 are considered opposites. One is just, if I take this binomial and multiply it by negative 1 like I did up here, it will result in this binomial here. This is useful in this example. So suppose I wanted to factor this polynomial. Once again, I look for a greatest common factor here. Okay, but notice that the greatest common factor of all of these terms is just 1. While this term, and this term, they all have x as a factor. Notice that this one does not. So the greatest common factor here is 1. Okay. So what I'm going to do is I'm going to group the terms in the order in which they appear. Okay, so I'm going to group them like this using the associative property of addition. Now, the greatest common factor of the terms in the first group is 4x squared, so I'm just going to factor that out. Similarly, the greatest common factor of the second term, or the second group, is 3. So I factor this 3 out using a distributive property in reverse. Right? But right here I should notice something interesting. I have x minus 2 as a factor in this term, and I have 2 minus x as a factor in this term. Notice that x minus 2 is just the opposite of 2 minus x. So what that means is I can write this binomial, 2 minus x, as just negative 1 times x minus 2, since they're opposites. Okay? But now that I've done that, I just simplify, because 3 times negative 1 is negative 3. Alright, and now notice that these two terms have a common factor of x minus 2. Since I have a common factor of x minus 2, I can use a distributive property backwards once again, factor that x minus 2 out, and I'm left with the following product. So this polynomial we completely factored into this product here. So this polynomial has been completely factored at this point. Alright, so the question that we answered today is, how can you factor polynomials completely by grouping? The first thing you want to do is determine whether all the terms have a greatest common factor, and if they do, you need to factor it out. Then you group the terms that have a common factor, and you factor out the GCF of each group, and you can use that GCF as a common factor to rewrite the polynomial in factored form. As a final step, you're going to want to check that none of the binomial factors that you're left with can be factored further, because you want to completely factor the polynomial.